Much love. Shout out to all the shooters, everyone looking to improve their shooting form by improving our understanding of the physics and mechanics of shooting. Specifically, this video is going to talk about how gravity works and specifically implications of that on arc. Try to keep this as simple as possible. Um, and I think that understanding this can really help any shooter because shooting is a physics equation. And if we understand how it works, we understand what we need to do to get the ball in the basket. So, gravity specifically, you probably have a good idea of how it works, but we should review that from a mathematical perspective. Casual observation of gravity is good, but mathematical understanding can only improve our ability to shoot. So the way that gravity works is it's an acceleration, 9.8 meters per second squared. Acceleration describes how fast something is changing speeds. Um, with relation to velocity, which describes how fast something is moving. So acceleration affects velocity. The relationship is, for instance, say that acceleration is 10. So something's velocity, if it starts at 0, it accelerates to 10, then it accelerates to 20, then it accelerates to 30. And that is basically how gravity works. The longer something is in flight, the faster and faster and faster it moves down in the air. So let's take a look at how this applies to shooting. So let's take a look at, sorry, trying to center this. Take a look at this theoretical shot. So the black line is the shooting motion from the starting point to the release point. As we shoot the ball, we're accelerating it upwards. Purple line is where we let go of the ball and it's now in flight. This is the fastest the ball will ever be moving upwards because at this point, gravitational acceleration is pulling it down. So this meeting right here, the release point, is the fastest the ball is moving. Over the course of the red line, at each moment on the red line, it is moving less fast than it was the moment before on the red line. So it's moving slower and slower and slower until it peaks. The green line, the velocity is 0. Where the red and the yellow line meet is when the velocity goes from positive to negative. So at the peak, the velocity is 0 and it starts to fall. And then the yellow line, like the red line, at each point along it, it is moving faster downwards than the previous point below it until it hits the ground when it'll bounce back up, or if it's affected by the rim or the net. So this is pretty simple, and if you understand this, honestly, like you'll probably understand calculus and math in school shouldn't be that hard. So hopefully that helps there. Well, let's talk specifically, briefly about how we can use this to improve our ability to shoot. So let's go ahead and skip to arc and think about jump shooting and how that affects arc. So jump shooting for arc. We're looking at Earth's gravitational acceleration as 9.8 meters per second. If we imagine the flight of the ball, we can as well imagine our body. So if we're creating arc, we're trying to push something up from below, releasing it at the fastest it's going. Similar to a ball in flight, the moment we leave the ground is the fastest we will ever be moving up. And at the peak of our jump, we're moving 0, and then we're falling. So for maximum range, we want to shoot on the way up, and specifically, we can release the moment we leave the ground for maximum arc. So Steph Curry, for instance, shoots on the way up. Moving on to Russell Westbrook. Westbrook, for his mid-range, shoots at the peak or on the way down. What this does is it allows him to get a shot off over a contest. And since he's near the basket, he doesn't necessarily need extra arc or range. So you can shoot on the way down or at the peak, but the consequence of that is we frequently have short misses. For instance, in this shot, Russ is shooting at the peak or on the way down, and the shot is flat and short. So we're missing out on potential power, which could go into arc which could make our shot, instead of coming back, land on top of the rim and roll in. So to show what we want to do for maximum range, and again, this is maybe something to be used from deep from the basket. You can shoot at the peak if you're near the basket, and it may help you get your shot off. So, like a ball in flight, the moment we release, or the moment we leave the ground is the fastest we're leaving. So this shot, which has tremendous arc, the ball is released the moment the feet leave the ground. The body continues to move up, and at this point is the peak where its velocity is zero. If we released the ball at this point, we would be missing out on the upward velocity, which we can impart into the ball and make it go up into the air. So that is basically gravity in a nutshell and how it applies to shooting for arc. So that's it. Hope this helps you in your understanding of shooting. And yeah, let me know what you think in the comments. For those of you who are into the really dense stuff, especially if you're wondering what this is from, this is an efficient shooting resource, which is on the way. It's going to be free, and we're going to blow shit up in the shooting world. So if you want to be on the subscriber list for that, or the newsletter list, email energyefficientbasketball@gmail.com. Otherwise, stay tuned on our YouTube and Instagram and Facebook, and we will announce the release whenever that happens, as well as continuing to make videos about this. So, hope this helps all shooters. Much love. See y'all in the comments. Peace.